Alright, our last segment of this unit is talking about power. Alright, power is the rate at which energy is transferred or the rate at which energy is done. So if we're talking about rate, that's how fast or how slow something's done. So we are considering time as part of this equation. So this is the first time in this unit that we're now thinking about time. Power depends on time. So how fast are you completing work? How fast is energy being transferred? So these are equation that we'll probably be using the entire time is P equals the work divided by the time. So how fast are you completing the work divided by how long does it take you, the time. Alright, so power is the amount of work done per unit of time. The units for power is going to be joules per second, or really it's watt. It may also look like a capital W. Alright, so we've already said that power equals work divided by time. Remember, work is measured in joules, time is in seconds. And then we just finished talking about work. Work is force times distance. So for some of these problems, you may have to actually find the work. So if you have the work and the time, feel free to use this equation here. But if you're given a little bit more information and you have to find the work, you may need this complete equation. So power equals work, we already said was force times distance. So FD divided by time. So you may need this version as well. This is just so you don't have to do 2 steps for the equation. You can do it all at one time. So I would write these down, and we're going to do some practice problems. Alright, number 1. A set of pulleys is used to lift a piano weighing 1,000 newtons. Alright, so the force of weight is going to be 1,000 newtons. The piano is lifted 3 meters. Alright, so there's a distance. It's moved a distance of 3 meters in 60 seconds. Wow, 1 minute to do that. This is so realistic. So the time is 60 seconds. So how much power is being used? We are looking for power. Alright, so we can't quite use just work divided by time, unless you just want to calculate the work and then plug it in. But I like to do it all at one time. So I'm not going to use this one. I'm going to use power equals force times distance, which is work, divided by time. Now you just plug in. So power equals, well, our force was 1,000 newtons, times our distance was 3 meters, divided by our time, 60 seconds. So we're going to need to simplify. We have 1,000 times 3, so that's 3,000 divided by 60. And 3,000 divided by 60 is 50. And remember, we were calculating power. So our units for power is going to be watts. Alright, very good so far. Number 2. How much power? So again, we're going to be looking for how much power is actually being used. If a force of 35 newtons, so we know that the force is 35 newtons, and it is used to push a box a distance of 5 meters, so we have a distance, 10 meters in 5 seconds. Wow, again, very realistic with the time. So time is 5 seconds. Okay, so I'm going to be using the same formula as last time. So power is equal to the work divided by the time, and work again was force times distance divided by time. Then you plug in, so power equals, the force was 35 times the distance was 10, all divided by 5. So go ahead and simplify with your calculator. You do 35 times 10 divided by 5 should give you 70. We're solving for power. Power is in watts, so 70 watts. Alright, let's look at number 3. So what is the power of a kitchen blender? So what's the power? We're looking for power. If it can perform 3,750 joules of work, so we know our work is 3,750 joules in 15 seconds. So our time is 15 seconds. So this one, it actually tells us how much work is being done. So we can use our original equation. Power is equal to the work divided by the time that it takes. So we can substitute power equals, our work was 3,750 joules divided by 15 seconds. So if you use your calculators and you do 3,750 divided by 15, you should get 250 watts because we're still measuring power. All right, number 4. How much work? Ooh, we're going back to work. So now we have to calculate how much work was being done. And using a 500 watt, that's power. Power is measured in watts. So the power is 500 watts microwave oven for 5 seconds. So our time is 5 seconds. All right, so let's just use our original equation. Power equals work divided by time. Let's plug in what we know. We know that the power is 500 equals, well, we're looking for the work, divided by the time is 5. We need to get work on a side by itself, so we are going to have to multiply by 5, multiply by 5. Cancels out over here, right? 5 times 500 is 25. 5 times 5 is 25. Add our 2 zeros, so 2,500 equals, that's the amount of work, 2,500. And remember, work is in joules. So it's 2,500 joules of work. All right, number 5. We're looking at number 5 now. How much work, so another how much work, so we're really looking for work now, is done using a 60 watt light bulb. So 60 watt, that's power. Power is measured in watt. So 60 watt light bulb for 3,600 seconds. So the time is 3,600 seconds. All right, use the same equation as before. So power is equal to the work divided by the time. Let's plug in what we know. We know the power was 60 equals the work is what we're looking for divided by the time, 3,600 seconds. All right, we need to get work on a side by itself. So again, we're going to have to multiply by 3,600. Cancels out on that side. What we do on that side, we have to do on this side. So times 3,600. So if you use your calculators and you do 3,600 times 60, wow, you get a big number. So we should get that the work was 216,000. We're talking about work, so it is in joules. So let's summarize all of this. So we've had 3 basic concepts that we've been learning about this unit. So the first one being work, energy, and lastly power. So let's look at energy first. So energy right here in the middle. Energy, the definition, is just the ability to do work. So it's the ability to actually do something. It is the ability to exert a force. So energy is the same, the exact same, no matter if you're running up the steps or walking up the steps. So it doesn't matter if you're running or walking. The amount of energy that you're going to use is the exact same. So keep that in mind. All right, now let's look at work. So if we look at work, work is the force applied times the distance moved. Because remember, work is calculated force times distance. So that's our physicist definition. Work is done whenever a force is used to move something. So a force has to be used and something has to move. So examples could be, you could be opening up a door, throwing a ball, lifting groceries, climbing stairs. All right, and again, work is the same, whether you are running up the steps or walking up the steps. Whether you're running up the stairs or walking up the stairs, you are exerting the same amount of work because you're using the same amount of force to carry your body and you're covering the same amount of distance. So, same work no matter how fast or how slow you're going up those steps. Now, let's look at power. So if we look at power, Power is a measure of how quickly work is done. So remember, work divided by time taken to do the work. So remember, we used power equals work divided by time. So power takes into account time. We want to know how fast or slow were you doing that work. So for power, it's greater when you're running up the steps. Power is going to be greater when you're running up the steps because you're completing that work at a much faster rate. Power is less when you're walking up the steps. It's taking you much longer, more time to complete that same amount of work. So for power, it matters how quick or how fast you do something. But with energy and work does not rely on time. Only power relies on time. All right, you've made it through our energy, work, and power unit. Good job.